In the library.
You want to do it at the library?
Yes.
We want to be free, Simon! We want to be free of your horrible oppression! Yeah, I know about that. I was going to say. Yeah. Have a look at the lecture notes up on Moodle. They have all of the answers to all of these. Have a look at the Richardson et al. 2004 paper. I know it's old, but it's still relevant. I'm old. I try to be relevant. Have a look, see what you think. And yeah, anything you want to discuss, we can do it in the lab this afternoon. Does that sound good? Awesome. Right, I will see you bright and early at 1:30. Yeah? Cool. Well, I'll see you then, folks. Thank you very much for your attention.
Changing genes in living cells is not easy. But recently, a new method has been developed that promises to dramatically improve our ability to edit the DNA of any species, including humans. The CRISPR method is based on a natural system used by bacteria to protect themselves from infection by viruses. When the bacterium detects the presence of virus DNA, it produces two types of short RNA, one of which contains a sequence that matches that of the invading virus.
More than 300 base pairs, and here you can see we got 0% of 8 pins, and the GC content and the melting temperature is in between the range. And however, we wanted to get of low GC content, but since we have tried to exclude any GGG or CCC runs, we have got no primer. So here you can see this is only the GG run we have got. And later on, we have taken the forward primer and the backward primer into the in silico PCR just to confirm our result of 333 base pairs, which we have got in the previous one, the primer 3 web output. And here this is all about our task 1.
So for the other part, we worked with another gene, which is the transforming growth factor beta 1. So mainly this growth factor is involved in different cell functions such as cell growth, cell proliferation, cell differentiation, and apoptosis.
And as a process, first of all, we have taken our gene and we have entered into the gene database inside the NCBI. And later we had taken the mRNA of the 3 similar species and also with the 3 unrelated species. And later on we had taken that sequence into the cluster W database.
So this is the multiple sequence alignment that we use cluster W, and from here we
have got just 33%. And you can see here there are very less similarities because these 3 species do not share a common ancestor. So that's why we can see there is a low percent of similarity between these 3 species. And here are the differences. Thank you.
This is part of the pseudomyelin clade of the bacteria, which are viral bacteria, but this is the only one which was classified as a viral. However, there are 6 cases in history with infection from the bacteria Peninsula. I don't experience
to identify the consensus genes between different species. So we have our interest was in caspase gene. It's a protease enzyme that has many essential roles in apoptosis, differentiation, neuronal remodeling, and inflammation. I'm sorry.
So the first step here was similar to our first step. Was to find first the genomic sequencing using the NCBI gene database. We selected
related species and then performed multiple sequence alignment on cluster W. It shows us the percentage similarity. So the percentage similarity between the alpaca and the koala was 65%, and between the alpaca and the red fox was 77%, and the koala and the red fox it was 82%.
The three related species that we decided to look at were all from the fish species. And the first one, just keep in mind sequence number 1, sequence number 2, and sequence number 3. These sequences, we have renamed them during our PCR, so we're just going to refer to them throughout this presentation as sequence 1, 2, and 3. Anytime you see these sequences, they'll be arranged in this order. Now, the first one will be Atlantic salmon, which is this species of fish, followed by rainbow trout, and also comparing with the northern pike.
So we suppose that we will have like what?